Hi and welcome to this new video. Today we are looking at BTQ, which is another one of those stock listed pure quantum companies. So if you want to make up your own mind whether that might make sense or not to invest into such a company, and if you want to understand what they're actually doing, then today's video is exactly the right thing for you, so stay tuned. As always, before we start the video, make sure to get yourself something to drink so you stay hydrated throughout. And with that, let's dive right into BTQ. So here we are on the starting page of their website and it says accelerating quantum advantage. And then we have this hovering animation in the background and it says explore products. So they are a product company. We will learn a little bit more about that in a second. Then we see here that they are partnering with different companies and research labs. So we see a couple of known names in here that we have featured also before. I think IDQ is, for example, one of them. If you haven't seen the video, you might want to go into the Hidden Quantum Champions playlist and check that one out. We also see university collaborations here, Radical, Semiconductor, and many, many more. So what are the products that BTQ is actually offering? Let's see. So our products. BTQ offers quantum solutions for both defensive and offensive capabilities to give your business an edge in the quantum age. I guess the quantum defense is, let's say, a term that also, given the current geopolitical situation, and especially quantum offense, might be something that people could miscoin. So I think it's not about building defense applications as in like steering rockets with quantum. I think it's a little bit different. So let's quickly look into that. So it says quantum defense is secure hardware. So quantum secure cryptographic hardware with unmatched efficiency and post-quantum security. So post-quantum security, as a quick explanation, is a security pattern that withstands the capabilities of quantum computers being able to do prime factorization at unprecedented speed. So what does that mean? Today's cryptography is based on the idea that prime factorization is a complicated task. If I give you, for example, a number that is composed out of two prime numbers, so prime numbers are numbers that don't have integer divisions. So for example, 5 you cannot divide into further integers, but 15, for example, can be divided by 3 and 5. So 3 and 5 are the prime numbers. Now, if I come up with a very, very large prime number and I multiply it with another large prime number, it is not an easy task for today's computers to actually figure out, if I give you the product of these two prime numbers, what are the prime numbers that this product consists of, even if it's only 2. And that means that you can build a asymmetric problem where you, like if you had for example, one prime number, you can easily figure it out, but it's hard to kind of just given the product figure out what were the initial prime numbers. More or less. It's a bit more complicated, but the idea is that you have this asymmetric problem, and that's basically what all our asymmetric cryptography is based on. Cryptography as in you write WhatsApp with your family and everything is encrypted in between. Cryptography as in you log into your bank account and you want to make sure that nobody in between can interfere with that. But also cryptography as in your government is storing all your sensitive and private data, or your medical institution is storing all your sensitive and private medical data somewhere. So cryptography plays an important role, and the idea is that once we have quantum computers, this cryptography can be broken. So now we are thinking about new ways to build cryptography that can withstand that. So cryptography that is not anymore based on the pure concept of prime factorization. And this apparently is a solution on the hardware level. So it says quantum secure cryptographic hardware. We will figure out probably later how that works. With unmatched efficiency and post-quantum security. Post-quantum security then usually refers to the post quantum era where you have a quantum computer that could otherwise crack the security of today. Then it says stablecoin network, QSSN. I'm getting a little bit of goosebumps when I already think about what is coming next. So it says quantum secure stablecoin network infrastructure for digital currencies and DeFi applications. I mean, from a technological standpoint, definitely very exciting. It is probably also on the hype scale very far up because it combines cryptocurrencies and quantum, the idea of quantum and stablecoin. So I don't know, maybe in that sense, quantum could even be kind of I don't want to call it the meme coin. I think that wouldn't be nice. But cryptocurrency and the idea of using quantum to make the cryptography more secure, right? I understand where that comes from. And then we also have the other side, right, which is the quantum offense side. So let's see how we can use quantum in an offensive way. So there's the one-shot signatures, OSS. So unforgeable digital signatures. Then we have the quantum proof of work. So the QPOW, pioneering blockchain validation with quantum efficiency, ensuring future-proof security and seamless integration. So ties back to what we've talked about before. And then there's the quantum toolkit, QRing, leverage the power of quantum-enabled nodes in consensus network to compute truly random numbers. And that again is then an application or let's say a toolkit that is probably being used to generate this higher level idea of this quantum secure network, right? Decentralized probably as well. We will learn probably more about that later on. BTQ is driving the future of post-quantum solutions. So BTQ was founded by a group of post-quantum cryptographers with an interest in addressing the urgent threat that a large-scale universal quantum computer poses to digital security. And then there's going to be more information available about that as well. We are paving the way towards a more secure and efficient digital future. I'm recording this roughly around mid of March, and we can see here in this news section that it's pretty much up to date. So 9th of March, latest announcement is BTQ Technologies awarded Australian government industry growth program support to accelerate QCIM commercialization. So QCIM is, I think, where was it? Here, up here, the QCIM is the hardware solution, so the chip that they've been announcing previously. And apparently the Australian government is involved in that. I mentioned before this company is stock listed, so you can also see down here there are three different stocks, three different stock exchanges where this is being traded. We see it's in Australia, in the US, in Canada. Canada, of course. Sorry, the Australian government was now confusing me a bit. In the US and then in Europe and Germany, in Frankfurt. Good. So let's quickly go through the products. And we see there's a lot of them. We have quickly skimmed through them. I think the most interesting one is going to be this QCIM on my personal preference. So let's quickly start with that one. It says quantum compute in memory. So the QCIM is a soft IP cryptographic accelerator architecture that combines symmetric and asymmetric encryption engines into a compact, low-power block optimized for both classical and post-quantum cryptography PQC. Designed for integration across a variety of process nodes, QCIM redefines secure element performance with cryptographic compute in memory (CIM) capabilities, crypto agility, and unmatched efficiency. Sounds like a lot of complicated stuff happening in there, right? Like asymmetric and asymmetric encryption. I'm not an encryption expert, but let's see if we can learn something else about these specific points down here in the key features. So Crypto, agile, and programmable. The world's first programmable crypto-agile cryptographic accelerator seamlessly supports traditional algorithms like the AES and the ECDSA and post-quantum standards including MLKEM and the MLDSS, cyber and dilithium. I think I'm not sure, like these post-quantum standards that I mentioned here, I know that there are some post-quantum standards or post-quantum ideas that have been proposed by NIST in the US. I'm not sure if these ones that we can see here are actually referring to those. Then there's the compute in memory. So cryptographic operations are executed inside the memory subsystem, reducing latency, power consumption, and data movement. This is probably similar to what we've been seeing with GPUs that solve specific problems. Now we have this cryptographic, so CPUs, but cryptographic processing units that are probably optimized to create this cryptographic input that is needed to do the cryptography. At least it looks to me like this is a application specific, so like an ASIC that is designed on the chip to do especially this task in a very efficient way. Then here it says soft IP for seamless integration, so delivered as a synthesizable soft IP compatible with leading foundry nodes like the TSMC 40 nanometers, 28 nanometers, the GF22 FDX and below, and off-the-shelf SRAM macros, adaptable across process nodes for ASIC or FPGA deployment. That relates to these are all information related to the chip design. These nodes which they are talking about is basically the size at which you are creating elements on the chip. There's this idea of Moore's law, right, that this size is always shrinking, and thereby with the same size of a chip, you can do more and more stuff. The reason why your laptop 10 years ago was not as performant as your smartphone is today is basically kind of a result of this idea of Moore's law. These 40 nanometers, they are still, let's say, comparatively big when compared to what is possible at the very, very lowest edge as of today. TSMC is the world's biggest foundry. Foundry means a service that is producing those chips. So BTQ is making the design. They are sending it to TSMC. TSMC is creating the chips. TSMC is this company in Taiwan, so Taiwan Semiconductor, which is making those chips, and where there's a lot of debate currently about the geopolitical situation as well. Then we have this next point here, ultra low power, so sub-microjoule energy usage per cryptographic operation, ideal for constrained environments like smart cards, wearables, and edge devices, so everything that is battery driven. However, I think this argument also holds for like bigger machines. If you just have more operations running, it's still interesting to be energy efficient, right, to work energy efficient. And then minimal area footprint, which is also, of course, important for variables and stuff, right? So fewer gates in SRAM than comparable PQ accelerators, reduces die area, BOM's cost, and improves thermal performance. So the bill of materials, BOM cost, is usually when you have a full-on device, like, for example, a wearable, a smartwatch. If you're taking all the components into account, and you're adding all of that up, it's the bill of materials cost of the whole device. So how much do you pay to buy every single component that is then being manufactured into the device? And of course, that has a huge impact on what will be the sales price. So if you can reduce the price of your materials, then of course that has an impact on the price at which you can resell stuff. So if you can reduce the die area and the BOM cost, then that's an interesting thing. So why QCIM? Secure and future-proof, integrates post-quantum readiness with backwards compatibility, ideal for long lifecycle products with evolving security needs, smaller, faster, greener, optimized for low power and smaller die area than all known post-quantum cryptographic cores in the market. So that's their these are the USPs, right? But I think that is one that is very, let's say, tangible to me. It's the smallest in its category. We have seen other ones already before in the series, right? And then flexible deployment. So whether you're building secure MCUs, payment chips, or custom ASICs, QCIM adapts to your needs and roadmap. And that's also pointing towards where we are heading, right? So you see payment chips, custom ASICs. So it is going to go into various different electronic applications, might be electronic payment applications, or everything that is an electronic device which has to communicate via a cryptographic channel with, for example, some other source on the internet. And you want to make sure that the information that is being exchanged is quantum safe. So that's the whole idea of this chip, right? You make a chip that is optimized to do this quantum safe communication. Then there are also some performance benchmarks here. So you see the AES acceleration output outperforms leading crypto coprocessors with 5 times faster parallel execution. You have the SHA-3 throughput, so achieves 6 cycles per byte in parallel mode, offering high-speed hashing with minimal power. And then the ECDSA P256 sustains 1 million, signing operations per second with base point randomization included. There's a lot of tables down here as well. I'm not going to go into those details, but what is interesting is to see the applications that are listed here. So let's quickly go through these. Smart cards are one of them. So ultra compact, low power cryptographic acceleration for next generation payment identity and access smart cards ready for post-quantum world. So it's not only about these little credit cards, which we are seeing less and less because people are paying with their phone, but also identity providers. So might also be going into your future ID or something like that, right? Then we see the edge IoT devices. We've talked briefly about this before, right? Like every tiny device that is sitting somewhere on the edge to the internet. So high speed, low latency security at the network edge. QCIM extends battery life and delivers quantum secure communication for billions of connected devices. Now, this could be your security surveillance camera that you put somewhere into your house that is connected to the internet, but it could also be your smart toaster, right? And of course, I leave up to you to decide in which cases maybe the cryptographic value of what is being communicated is more important, or maybe also the amount of data that is being communicated is more important. Because keep in mind, this is relevant for the data that is being communicated, and its efficiency and all of its advantages really probably only come into play at the moment where you also communicate data. You see also post-quantum PKI, so hardware-accelerated key generation, signing and encryption of for enterprise and government PKI systems, migrating to post-quantum security. Then you have the secure elements, so drop-in crypto agility for mobile devices, embedded systems, and payment terminals, programmable to evolve with future standards. So you see already that like payment terminals here, it's getting very specific, targeting finance applications. And then we see the hardware wallets, so bulletproof private key protection in a tiny footprint. QCIM brings quantum resistance to wallets without compromising speed or portability. And for hardware wallets, for everyone who's not aware with this concept, these are devices that you can use basically to store the key that you need to do. That is basically your wallet in the world of cryptocurrencies. And So that also is a target here to work on crypto-related things. Okay, let's quickly also check out the QSSN, because what would be the analysis without looking at the probably most exciting topic in terms of hitting all of the hype topics right now. So quantum secure stablecoin network is a quantum secure stable. So the QSSN is a quantum secure stablecoin network that enables secure digital transaction through post-quantum cryptography. Built for the future of digital finance, QSSN provides quantum-resistant security for stablecoins, digital currencies, and secure payment systems. So about the infrastructure, the QSSN revolutionizes stablecoin security by implementing post-quantum cryptography to create an unbreachable foundation for digital currency transactions, stablecoin operations, and secure financial networks. The key features are quantum secure transactions, stablecoin infrastructure, stablecoin ready, and the financial institution grade. In the quantum secure transactions, it says post-quantum cryptographic protocols ensure transaction security against both classical and quantum computer attacks. Stablecoin ready, built specifically for stablecoins, CBDCs, and other digital currency instruments with quantum resistant security. Then we have the stablecoin infrastructure, secure decentralized network infrastructure specifically designed for stablecoin operations and digital currency management. And then the enterprise level security and compliance designed for banks, payment processors, and financial services. Key capabilities are also mentioned here. I'm not going to go into all of these now. Why should anybody use that? So quantum resistant security is one of the key reasons, built with post-quantum cryptography to protect financial transactions against future quantum computing threats, ensuring long-term security for digital financial infrastructure. Then global stablecoin network, decentralized network infrastructure enables secure stablecoin operation anywhere on Earth, perfect for international transfers and cross-border payments. Here I wonder how these nodes are being set up. So does every single node need, for example, one of those chips that we talked about before, or can everybody just host a node, or are these nodes only for banks, or how is that? How would that be implemented? Probably we will learn a little bit more about that below. And then future-ready stablecoin platform designed to support emerging stablecoins, CBDCs, and next-generation digital currency instruments with unpromising quantum security standards. So we see designed to support emerging stablecoins. So it is not maybe just the stablecoin itself, but it is a framework for stablecoins to build stablecoins upon. Maybe it's that. Maybe I'm not getting that completely right. So stablecoin issuers are a use case. So probably it is something that is underlying and you build your stablecoin on top of it. So secure infrastructure for stablecoin issuance, management and operations with quantum resistant security protecting reserves and transactions. Then central banks enhance security for CBDC implementation and digital currency operations with post-quantum cryptographic protection. Since this has popped up multiple times, so the CBDCs are central bank digital currencies. So they are basically the digital euro, the digital US dollar, the digital renminbi, which I think in China already exists. They come with multiple different concepts that are new. So it is not the same as paying with a credit card and then digitally paying euros, because the CBDCs are usually handled by the central banks, so by the central bank authority itself, whereas the euro transaction, for example, via Visa, a digital transaction, is not the same thing because it is being handled still by private banks. So very interesting concept. If you have never heard about it before, I definitely encourage you to check it out, because a lot of central banks are currently looking into this, are working on concepts or have already worked out concepts about this, and would like to kind of push this into society, and you gotta make sure that you learn about it so you can have an opinion, an informed opinion on this topic. And then finally, we see here the DeFi protocols, so quantum secure stablecoin integration of DeFi platforms, DeFi, ensuring long-term security for automated market makers and lending protocols. And then there's more specifications down there. Besides that, there's also the quantum offense part, right? We've seen those ones before as well. Let's quickly skim through that. I don't want to go into all of the details. The quantum random number generator, Q-ring, we've seen things like this before. Okay, there's also some math in here. So for everyone who would like to go really deep in and then learn about the formulas and the complexity behind it, I think there is definitely something to learn here. So how does it work? Q-ring operates through quantum consensus networks, QCNs, that achieve full peer-to-peer connectivity via quantum key distribution, QKD. Consensus is achieved through a majority consistency of pairwise QKD bit strings, where nodes verify each other and honest majority determines network connectivity. So I think this idea of having network-based consensus is also very fundamental to, for example, Bitcoin or other cryptocurrency. So definitely some interesting piece of math behind all of this. And yeah, if you like it, you might want to check that one out as well. Now, I don't want to stretch the video for too long, so I see that besides that, there are also other products here. I encourage you to check them out if you really want to do, let's say, the full 360 view on the company. There are also some additional resources, right? We've seen there's a news section. We see there's a podcast here as well. If anybody from BTQ watches, happy to join also as a podcast guest once. There's also a blog, Research Insight and the Quantum 101 here, which is probably a, let's say, basic information about quantum. As per usual, there's also information about the company, and I would love to quickly also dive with you into this, because usually it's also interesting to see the people behind the company. So BTQ delivers quantum advantage through cost-efficient solutions that create new markets and disrupt existing industries. Meet our team, so founded by a group of cryptography experts, scientists, and engineers. BTQ has offices in Vancouver and Sydney. BTQ is involved in business development and research and development in key markets such as Taipei, Toronto, and Seoul. Here we see the people behind it. So we see they have like a chief executive officer, chief quantum officer, but also other functions like head of communications. So you see it's like a proper company. It's not just scientists sitting there. You see here the different offices, 3 of them, and the key markets. There's also a little map down here with more than 3 offices even. So the closest to me is Vaduz, which is in Liechtenstein. I'm here in Switzerland. And then there's also some history, I guess, here about the pioneering quantum computing. So I guess the founding story of the company. CBOE public listing. So I guess that's when the company went public, maybe not. And here we see the NIST, right? That's what I mentioned before, the National Institute of Standards and Technology, which came up or which issued this standards for post-quantum cryptography. And then there's also, of course, here some careers available as well. Now, from my point of view, an interesting piece of technology, especially if you believe in the fact that we are moving closer to the day and age where quantum computers can break cryptography, because then we do need some solution for post-cryptography. So that's for sure interesting. The whole, let's say, blockchain discussion, I'm not an expert on that. I just see, of course, there's a lot of interest and there's a lot of technicalities and interesting things about that. What I do understand a bit better is the, let's say, chip world and chip manufacturing world. And I mean, building and taping out your own ASIC is definitely a great challenge, and it shows that as a company you have done something great if you manage to actually produce something like that, because many companies, they never really make it to this point. So I think that shows that there is also some, like, of course, besides the concept, which I think makes sense if you believe into that at some point quantum computers may crack cryptography. The concept of making a dedicated chip solution for that, I think, is probably something very interesting. But yeah, as I said, everyone can make up their own mind. What is your opinion on that? Let me know down in the comments below. And as always, if you don't want to miss out on the next episode, which is again going to be about an interesting company from the quantum technology space, then make sure to subscribe to this channel. See you in the next one. Until then, bye bye.